Let's talk about differential equation. Differential equation is an equation involving a derivative. Let's take example 1 here. You have dy over dx equals secant square x plus 2x plus 5. So how to solve that? How to solve for y? Well, what you want to do first is you want to move dx to the other side. So you have dy equals quantity secant square x plus 2x plus 5 dx. And in order to solve for y, you want to take the integral of both sides. So what happens is you get y is integral of secant square x is tangent x. And integral of 2x is x squared. And integral of 5 is 5x. And be careful, a lot of students forget to put plus c, where c is any real number. Now think about it. When you take the derivative of 9, it's going to be 0. When you take the derivative of negative 1.5, it's going to be 0. So c could be any real number. Now when you have this solution, where we don't know the exact value of c, we call it general solution. When you are able to find the value of c, then we call it particular solution. In order to find a particular solution, they need to give us more information, which we're going to talk about in example 2. Now in example 2, we need to find the particular solution to the equation dy over dx is e to the x minus 6x squared, whose graph passes through the point 1, 0. So notice the key word here is particular solution. That means we're able to find the value of c after you take the antiderivative or integral of both sides. So let's start with dy over dx. Now, again, when you want to solve this for y, you want to move dx to the other side, so you get dy is quantity e to the x minus 6x squared dx. And you want to find the integral of both sides. So what is y? Y is going to be e to the x minus x to the third, and then there will be 2 plus c. We could find the value of c because it says the y will go through the point 1, 0. That means when y equals 0, x will be 1. So what is the value of c? c is going to be 2 minus e. So that is the value of c. So what is our particular solution? It's going to be y equals e to the x minus 2x cubed plus 2 minus e. This is a particular solution where the graph will pass through 1, 0. For example 3, we have find the solution to the differential equation f prime of x equals e to the negative x squared, for which f of 7 equals 3. So what does it mean when they say f of 7 is equal to 3? That means when x equals 7, the y value will be 3. So you might want to rewrite it as 7, 3 for f of 7 equals 3. Now f prime of x is the same thing as dy over dx. So you could rewrite this expression as dy over dx equals e to the negative x squared. But we got a problem here because even though you move dx to the other side, you cannot find the integral of e to the negative x squared. I mean, you could try if you want. Maybe it's better if you try it and struggle with it, and you'll find out that you cannot find the integral of that. So what do we do? In this case, what we need to do is we have to use a fundamental theorem of calculus. So if you remember fundamental theorem of calculus, that implies that f of x is the integral. Now what is the x value here? 7, right? 7 to x. Integral goes from 7 to x. And then it's going to be e to the, we cannot use the variable x because we're using it over here. So we want to use probably t and dt. Okay? And then what's the y value? Y value will be 3. Now check this out. When x equals 7, right? When you plug in 7 for x, that becomes 7 as well. So what is the integral from 7 to 7? 0. But f of 7 has to be 3. That's why we have to put 3 over here. Let's say that instead of 7 comma 3, let's say you had 2 comma 5. Then instead of 7, you got to put 2. And instead of 3, you got to put 5 to make the statement true. Let's take the derivative. What is the derivative of f prime of x? F prime of x is going to be the derivative of this, right? Which is e to the negative x squared. Well, what's the derivative of 3? 0. So we do get back to the original f prime of x. So this is the farthest you could go under a given situation.